Hello students, now we are going to find the dative bond in the given species. Students की కాంపిటేటివ్ ఎగ్జామ్లో క్వశ్చన్ ఎలా అడుగుతుంటారంటే డేటివ్ బాండ్ ఉన్నటువంటి మాలిక్యూల్స్ ఏమిటో కనుక్కోమంటారు. సమ్ టైమ్స్ ఏ మాలిక్యూల్లో మోర్ డేటివ్ బాండ్స్ ఉన్నాయి కనుక్కోమంటారు. దట్స్ వై దీని గురించి డిస్కషన్ చేద్దాం. ఇంపార్టెంట్ కాన్సెప్ట్. ఫస్ట్ ఆఫ్ ఆల్ now you take example NH4 plus ion. The name is ammonium cation. గుర్తుంచుకోండి, cations ని ఎండింగ్ లో IUM అని చదువుతాం. అమోనియం క్యాటయాన్, కార్బోనియం క్యాటయాన్, హైడ్రోనియం క్యాటయాన్, IUM అంటాం. IUM represents positive cation. Now we take rough bonding, hydrogen, 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 hydrogen. You know, hydrogen makes a single bond, single bond, single bond, right? Thus, in this species, there exist 4 single bonds, clearly. Now, what is the atomic number of nitrogen? 7 and what is the nearest inert gas? Neon 10 and atomic number 10. చెప్పండి డిఫరెన్స్ ఎంత? The difference is 3. 7 and 10 difference is 3. So nitrogen in general forms 3 bonds. బట్ ఏముందండి ఇక్కడ స్పీషీస్లో ఎన్ని బాండ్స్ ఉన్నాయండి? 4 ఉన్నాయి. అంటే దట్ ఈస్ స్పీషీస్లో ఉన్నటువంటి 4th బాండ్ 3 బాండ్స్ ఓకే, 3 బాండ్స్ ఓకేనండి. 4th bond extra bond. 4th is the extra bond. So this extra bond, this is extra bond, extra bond. This extra bond is nothing but a dative bond. This is the dative bond. So the right geometry is nitrogen, one bond, covalent bond, whereas this is the dative bond. This is the dative bond. You know, nitrogen configuration 1s2, 2s2, 2p2, 2p1, 2p1, 2p1. For hydrogen, now the lone pairs are given for the vacant orbital of H plus ion. Clear? This is one example. Now I go to another example. Hydronium ion. Hydronium ion. Hydronium ion. In hydronium ion, central atom oxygen. Now, hydrogen makes single bond, single bond, single bond. The overall species has a charge of plus. Oxygen number is 8. Nearest inert gas is neon 10. The difference gives bonds it can make. What is the difference between 8 and 10? 10 and 8 difference is 2. So it can make maximum 2 bonds only. But here in the species there is a extra bond. Extra bond is there. There is a extra bond. This extra bond is nothing but dative bond. Extra bond is nothing but dative bond. Thus the species has a dative bond. Single bond, whereas this is the dative bond. This is the dative bond. It is the dative bond. Lone pair are donated by this one. Still it is having one more lone pair. You know, what about oxygen? Oxygen is 1s2, 2s2, 2p2, 2p1, 2p1. Now one for hydrogen, and this pair for H plus ion. Thus dative bond is formed between, that is oxygen and H plus ion. Clear? Now one more example we are going to discuss. One more example. That is, we take SO2 molecule. SO2 molecule. Now rough bonding. Oxygen makes a double bond. Okay. Sulfur number 16. It has 6 valence electrons. So already used 1, 2, 3, 4, here 5 and 6. Anyhow, one lone pair. One lone pair it has. Now what about sulfur number? Sulfur number is 16. Nearest inert gas is argon 18. What is the difference between them two? So it has to form two bonds only. But in this structure we have more than two bonds. That means why say what? This is the extra bond. What is the extra bond? Here is the extra bond. This one is okay, whereas this one is the extra bond. So the extra bond represents what? Dative bond. The extra bond represents dative bond. So I clearly say SO2 has a dative bond. It has a dative bond. Inert oxygen has 6 valence electrons. So it has vacant orbital. Whereas sulfur has how many? Actually it has 6 valence electrons. One used. Still it is having 4 electrons. Out of 4, 2 are donated to this one. So SO2 has one dative bond. SO2 has one dative bond. Now I go for SO3 molecule. We go for SO3 molecule. Similarly, we can find the dative bond in this one. Now SO3 molecule. SO3 molecule rough geometry is like this. You know sulfur number is 16. Nearest is argon 18. The difference is 2. So it has to make 2 bonds only. The rest of bonds are taken as these are extra bonds. So the extra bonds represents which one? Dative bonds. These are dative bonds. Dative bonds. So clearly SO3 has how many dative bonds? There are 2 dative bonds. Thus the dative bond is found in the given molecule. Now we go for one more species. Let us see SO3 minus 2. You know what is the geometry of this one? Sulfur surrounded by 3 oxygens. We give -1 unit to each oxygen. So O minus makes single bond. Here is a double bond. Okay. Now carbon number is 6. Nearest inert gas is neon 10. The difference is 4. So it has to make 4 bonds. Now how many bonds it made? 4 bonds. I think there is no extra bond. No extra bond here. No extra bond. So we say no dative bond in carbonate species. There is no dative bond in carbonate species. Clearly? Now we go for sulfate anion. Sulfate. We take sulfate anion. Now sulfate structure is SO4 minus 2. Sulfur surrounded by 4 oxygens. Now give -1 each to oxygen atom. Now O minus makes a single bond because it has 8 plus 1 means 9. Nearest one neon 10. The difference is 1. It makes 1 bond. Here 1 bond. Oxygen free oxygen number 8. Nearest one neon 10. The difference is 2. Makes 2 bonds. This is the geometry of sulfur. Now we go for sulfur atomic number is 16. Nearest inert gas argon 18. The difference between these two is 2. So sulfur has to make only 2 bonds. It has to make only 2 bonds. So remaining bonds are extra bonds. The remaining bonds are taken as extra bonds. Now you take 2 bonds, especially that is one single bond and single bond. These two are the extra bonds. Generally the extra bonds are made into dative bonds. So what is the geometry here? This is a single bond. Here is a dative bond. Thus sulfate has 2 dative bonds. Now this time I go for phosphate anion. PO3, PO4 minus 3. Phosphate anion. PO4 minus 3. Here is the rough geometry. Oxygen O minus, and here is the O minus double bond. What about phosphorus atomic number 15? Nearest inert gas is argon 18. What is the difference? 3. So it makes how many bonds? 3 bonds. But the molecule is making how many bonds? 5 bonds. So 2 bonds are extra bonds, or the pi bond is taken as the that is double bond is taken as the extra bond, extra bond. So the extra bond is made into a dative bond. Extra bond is made into a dative bond. Thus the species has a dative bond. It has a dative bond. Thus the dative bonds are found. Similarly, I go for complex compounds. I go for the complex compounds. Before going to the complex compounds, we will explain some molecules having dative bonds in the complex. Now you take inorganic benzene. Inorganic benzene. Inorganic benzene is formulated by B3N3H6. Now the structure of benzene, it has the structure similar to benzene. That's why it is known as inorganic benzene. It is known as inorganic benzene. Boron, nitrogen, boron, nitrogen, boron, nitrogen. Okay. What about boron? Boron configuration 1s2, 2s2, 2p1, 2p0, 2p0. Now in excited state it makes 2s is promoted to the vacant orbital. Thus it is making how many bonds? 3 bonds. 1 bond, 2 bond, 3 bonds, still it is having a vacant orbital. 1 bond, 2 bond, 3 bond, still it is having a vacant orbital. 1, 2, 3, still it is having the vacant orbital. What about nitrogen? Nitrogen number is 7. So configuration 1s2, 2s2, 2p1, 2p1, 2p1. Now it used 1, 2, 3 for bonding. 1, 2, 3 for bonding. Still it is having a pair of electrons. 1, 2, 3 for bonding. Still it is having a pair of electrons. 1, 2, 3 for bonding. Still it is having a pair of electrons. Thus what happens? There will be presence of lone pair of electrons and vacant orbital. So it makes a dative bond. Here a dative bond and here is dative bond. Thus in this molecule there are how many dative bonds? 3 dative bonds. In B3N3H6 this is called borazole or borazine. Borazine or borazole. Borazole. It has 3 dative bonds. So the structure is taken like this. Boron, boron, here nitrogen, 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 here boron. That is, this is hydrogen, hydrogen, hydrogen. Now I told you, after bonding, they are having vacant orbital. Borons are having vacant orbital. Nitrogens are having lone pair of electrons. That's why we expect that is a pi bond between nitrogen and boron. Nitrogen and boron. Okay. So there are 3 pi bonds here. This is also known as dative bond as well as pi bond, because already bond is between these two. So the other bond is the extra bond is taken as the pi bond. Okay. Similarly, dative bonds are also found in dimers of beryllium chloride and aluminum chloride. Beryllium chloride and aluminum chloride are having dimers. That is, when we take beryllium chloride dimer, when we take beryllium chloride dimer, you know beryllium number is 1s2, 2s2, 2p0, 2p0, 2p0. Now in excited state it become 2s1, 2s2 become 2s1, 2p1. Still it is having 2 vacant orbitals. So this is having the vacant orbitals. There are 2 vacant orbitals. There what happens? Chloro bridge is developed between chlorine. You know chlorine number is 17, means 10 plus 7. It has 7 valence electrons, used 1. So remaining are 3 lone pairs are there. 3 lone pairs. Now this chlorine do what? This chlorine donate lone pair of electrons to the vacant orbital of this one and lone pair of electrons to the vacant orbital of this one. Thus between these two a dative bond is formed. This is also known as chloro bridge. One more point is, in this one beryllium is making 3 bonds. So in this case beryllium has covalency of 3. Anyhow, this is called chloro bridge. Similar manner is explained in case of Al to Cl6. In Al to Cl6, aluminum has 1, 2, 3 bonds here. Similarly, aluminum has 1, 2, 3 bonds. After bonding aluminum, what about aluminum? 1s2, 2s2, 2p6, 3s2, 3p1. Still it is having vacant orbitals. Now, if this is promoted to this one, thus we have after bonding 1, 2, 3 bonding. After bonding it is having still vacant orbitals. Okay, you learned chlorine has lone pair of electrons, 3 lone pair of electrons. So what happens? There will be overlapping between these two. Thus a dative bond is formed. This is also known as chloro bridge. Okay. Thus the dative bonds are explained in simple molecules. Similarly, we go for the complex compounds. In complex compounds, the students are feeling about doubt. How many? One atom can make how many dative bonds, and one ion can make how many dative bonds, like that. When you take nickel atomic number is 28. The next inert gas for this one is krypton 36. What is the difference between these two? 36 minus 28. That means how much? 8. So 8 by 2 gives number of dative bonds. So it can make how many dative bonds? It can make 1, 2, 3, 4 dative bonds with CO molecule. Thus Ni is tetracarbonyl compound. Similarly, you go for iron. Iron number is 26. Next inert gas is 36. The difference between these two divided by 2 gives 10 by 2 means 5. So this can make maximum 5 bonds. Thus, iron is coordinated by 5 dative bonds. It is coordinated by 5 dative bonds by the CO molecules. Clear? That's why the formula of this compound is CO. FeCO taken 5. Similarly, we go for iron plus 2. Here iron plus 2. Iron number is 26. Last 2 electrons last. So remaining are 24. Nearest inert gas is krypton 36. The difference is 36 minus 24 means 12 by 2, which means 6. So that it makes 6 bonds, 6 dative bonds with the complex compounds. 1, 2, 3, 4, 5, 6 cyanide ions or water molecules. Clearly, thus the number of dative bonds are found. Clearly. Now similarly we go for Zn plus 2. Zinc atomic number is 30. Minus 2 electrons last. Overall it is having 28. Nearest one is krypton 36. The difference is nothing but 36 minus 28 by 2. 8 by 2 means 4. So covalency of zinc is what? It is 4. 1, 2, 3, 4. That is, it can coordinate with 4 ligand molecules. Thus the dative bonds are explained. Thank you.